Hello and welcome to the first of the many videos that we'll have for the sports. And as you know, this setup, because of the pandemic, we cannot do live classes anymore. So we just have to do with what we can. And since wala din naman akong iPad, I think it's a better way for you to learn the subject material in more detail if I present bite-sized videos on how to solve some of the equations, some of the models that we have in the slide. So for the first few videos, we're going to discuss a couple of problems involving the monopolist profit maximization problem. So as you know, the monopolist profit is given by the equations already in the slide. So it's given by E of Q times Q minus C Q. And as you know, this portion is your revenue. This is the monopolist revenue. And on the other side, you have your monopolist cost. So all you have to do is to identify the level quantity that will maximize this firm's profit. So to do that, you just have to take partial. You already know this, so we have partial of pi with respect to, or since single function lang naman siya, you can just type in d pi q equals, and as you know, this is a product. It's a product of two functions, so we have to follow product rule. So we have p q plus p prime q is q minus c q and set it equal to 0. So to maximize the monopolist's profit, we'll have to identify q star such that the marginal revenue equals marginal cost, or this revenue function, this marginal revenue function must be equal to c prime q. Of course, it will only make sense if we come up with an actual profit function, or with an actual function for this inverse demand. So for simplicity, let's come up with a rather simple example. Let's consider the exercise in the first slide. Let's consider this. Suppose your demand function is Q equals, so you have 100 minus 2P, right? And assume that the cost function C Q is equal to Q. Now solve for Q star. Now when you see this, this is your demand function. So the goal here is to convert this into an inverse demand function. So price as a function of quantity. Then we solve for the maximum, solve for the profit maximum. So the inverse demand function is equal to, it's going to be 100, and that's going to be PQ, so that's going to be 100 minus Q, 100 minus Q divided by 2. Right? Or simply put, that's going to be 50 minus 1/2 Q. Right? So the profit function pi becomes 50. So 50 minus 1/2 Q times Q minus 2Q. Okay. And profit maximum, of course, so coming from this function, let's copy insert profit function. So solve for the derivative. So it's going to be d. It's going to be d5 over dq equals. So for simplicity, you can just multiply this q within the bracket para mas madali na ma-derive yung derivative for the revenue. Easy for you to get the modular revenue easily. So here you can just multiply this q across the bracket term. So that's just going to be 50 minus q minus 2 and set it equal to 0. Bracket minus 2 because of this. So you take the derivative of q, it becomes 2. Right. So we get 48. We get 48 minus q equals 0. And therefore, the maximum profit, or therefore the quantity that maximizes the firm's profit, is equal to 48. Alright? So it's just a matter of reviewing this concept. Marginal revenue must be equal to the marginal cost.